Now we're going to look more in depth at tangent lines. As a reminder, a tangent line, which also could be a segment, intersects the circle at exactly one point, and that point is called the point of tangency. So if you're looking at the figure to the right, line AB is a tangent line because it touches the circle at exactly one point, which is point A, and that is called our point of tangency. If a line is tangent to a circle, it will be perpendicular to the radius drawn to the point of tangency. So if you draw the radius AP, then the tangent line AB will be perpendicular to the radius. All right, so in our first couple examples, all we're deciding is if segment AB is tangent to circle P. And in order for it to be tangent to circle P, then we have to know that the angle is a right angle. The only way to know that if it's a right angle is to use the Pythagorean theorem. Remember that the Pythagorean theorem is given to us by a squared plus b squared equals c squared. A and b represent the legs, and c would be the hypotenuse. The legs are going to be what form the right angle, and then the hypotenuse will be opposite the right angle. So in 1, if angle BAP is a right angle, right? If this were a right angle, then 8 and 15 are the legs, and the hypotenuse is 17. The hypotenuse has to be the longest leg. We don't know that it's a right angle, so what we're going to do is we are going to plug in the potential legs and hypotenuse and see if it works. And if it does, then we know it's a right angle. And if it doesn't work, then we know it's not a right angle. So our potential legs are 8 squared and then 15 squared. And our hypotenuse, if it's a hypotenuse, is 17. And then we're going to square that. So we're just going to do the math here. 8 squared is 64. 15 squared is 225. And 17 squared is 289. Now we're going to add 64 and 225, which is 289. So since we got an equivalent statement, then we know that yes, AB is tangent to circle P, because it created a right angle, and it has to have a right angle. On number 2, you're going to need to make sure you look at these pictures very carefully. So if it's a right angle, it's angle A, that's going to be the right angle, which means 11 is the leg and 4 is the leg. That 5 is not the hypotenuse. It's just the outside piece of the hypotenuse. So what you have to see is that we're missing this length right here. Okay, but that's a radius, and we know that AP is a radius, so that means that that length right there is also 11, and that would mean that our potential hypotenuse would be 16. So now we're going to set up leg squared plus leg squared equals our potential hypotenuse squared. Again, if this statement is true, then we know it's a right angle, which means AB is tangent. And if it's not true, then it will not be tangent because it will not have a right angle. So 11 squared is 121, 14 squared is 196, and 16 squared is 256. If you add 121 and 196, you will get 317. 317 does not equal 256, so that means that that is not a right triangle, which means that AB is not tangent to the circle. In our next set of examples, we are going to be finding a missing value. So again, like the last one, you want to make sure that you're paying very close attention to what's given, what's missing, what pieces would be the legs, what pieces would be the hypotenuse. You are told that JK is tangent to circle L, and you're looking for x. So we do know that this is a right angle, which means we have a right triangle, and we are going to be using the Pythagorean theorem in all of these problems. You just got to make sure you put the right numbers in the correct place. So on this example, my legs would be JK, which is x, so x squared, and JL, which is 11 squared, equals. The hypotenuse is LK. That 7 is just the outside piece. So kind of like the last problem that we did, this missing piece on the inside is a radius, which is equivalent to JL, because JL is also a radius. So we're going to let that be 11, which means that the hypotenuse will be 11 plus 7, or 18. So x squared plus 11 squared equals 18 squared. All right, so we're going to do x squared, 11 squared is 121, 18 squared is 324. Now we're going to subtract 121, which gives us x squared equals 203. And then we will use a calculator to do the square root of 203. Depending on your calculator, if you're using Desmos or if you're using a 36X Pro, it's very possible that you're going to get a square root value when you plug it in, but you can turn it to a decimal. So to get rid of that square, we need to square root both sides, and the square root of 203 is approximately 14.2. This is not going to be degrees because this is the length of a segment. If we had units like inches or feet or meters, we could put meters. You could also just write units if you wanted to, but you don't have to. And again, I rounded to the tenths place because it told me to round to the tenths place. In our next example, again, we are told JK is tangent to the circle, so we know that's our right angle. So our legs are going to be x squared, and the other leg would be MJ. We're told LJ is 11, which is a radius. MJ is a diameter, so it would be 11 doubled, or 11 plus 11, which would be 22 squared equals, and the hypotenuse, we do have the whole length of MK, which is going to be 25 squared. So 22 squared is 484. 25 squared is 625. We are going to subtract 484. So 625 minus 484 is 141. And then to get rid of the square, we're going to square root both sides. This is not a perfect square, so we are going to round. It should be 11.9. The 8 should round up to a 9 because it's followed by a 7. And again, this is not degrees, this would be units. We have two more similar examples to the previous two. So on the one on the left, we are looking for x, which if JK is tangent to circle L, then we know that angle J is a right angle. So that means that JK is a leg, which is 6.4 squared, plus the other leg would be JM. They give us that the radius is 3.5. So that would mean that JM would be 7, so 7 squared. And our hypotenuse is MK, which is x, and then squared. So I'm going to do 6.4 squared, which is equivalent to 40.96. I'm not going to round at this point. I'm just going to leave it as a decimal. 7 squared is 49 equals x squared. When we add 40.96 and 49, that's going to give us 89.96 equals x squared. Now we'll take the square root, and again, we're going to round to the nearest tenth. which would be 9.5 units. 4 bumps up to a 5 because it's followed by an 8, so 9.5. Last one of these types. On this one, if KJ is the tangent, then angle J is your right angle. One of our legs is KJ, so I'm going to do 7 squared. The other leg, we know that JL is X, which means LM is X because it's a radius. And so that means that the entire length of JM is 2X. So plus 2X squared. I'm going to make sure I use parentheses because I'm not just squaring the X, I'm squaring the 2 and the X. And then the hypotenuse is KM, which is 25 squared. So 7 squared is 49. 2x squared means 2x times 2x. So you need to square both the 2 and the x. So that will become 4x squared equals 625. The next thing I'm going to do is subtract 49. 625 minus 49 is 576. Then I'm going to take 576 and divide by 4. That's going to give me x squared equals 144. And then finally square root both sides, and this one is a perfect square. The perfect square of 144 is 12. So 12 units would be the length of x in this particular problem. So the radius would be 12, the diameter would be 24. But you're just asked to find x. There are a couple more tangent line properties, so we've got 2 more. The first one says that if 2 segments from the same external point are tangent to the circle, then the segments are congruent. So let's break that down a little bit. 2 segments, that's AB and CB, from the same external point. That external point, external means outside, is point B. If they're tangent, we know that they're going to be both perpendicular to the radii, but that also means those segments are going to be congruent. So AB will have the same length as BC. So we'll try a couple examples using this property. So in our first example, we're looking for the value of PQ. So not just X, we want to know the length of segment PQ. What we do know is since these are tangent, they touch the circle at one point, P and R, and from point Q, that means these segments are congruent. So to solve 14x minus 13 equals 8x plus 5. Keep in mind these are segments. Don't try to add them and set them equal to 180. That has to do with angles and degrees, not segment length. They are equal to one another. It also says in the directions, assume the tangents that appear to be tangent are tangent. So it's telling you that QP and QR are tangent, which means that they're going to be congruent since they meet at point Q. So to solve this, hopefully there's no issue solving this. Subtract 8x and add 13 to both sides. That gives me 6x equals 18. Divide both sides by 6, so that means x equals 3. We're looking for PQ, so I'm going to do 14 times 3 minus 13. 14 times 3 is 42, and if you subtract 13, that is going to give you 29. Now, if you want to make sure that you did this right, plug 3 into QR as well. 8 times 3, which is 24, and 24 plus 5 is 29. That's kind of a good way to check and make sure that you didn't make any careless mistakes when solving, because we know that it can happen. But because when I plug it in for both of them, I get 29, then I know I've done this right. Okay. So this one, we are looking for the value of ST. and ST is the diameter. So if I can find the radius, then I can find the diameter. So you might want to make note of that. Remember that the diameter is always double the length of the radius. We know that PQ is 4x plus 2, and we know QR is 7x minus 19, and we're told QU, that whole long segment right there, is 34. I am going to wait to use that 34 for just a minute. What I do know is that since QP and QR are tangents that meet at point Q, then I know their lengths are congruent. So the first thing I'm going to do is I'm going to set 7x minus 19 equal to 4x plus 2, and I'm going to solve to give me x, which will then give me actual lengths of QP and QR. Then I'll use that to find more. So I'm going to subtract 4x from both sides, add 19 as well to both sides. That's going to give me 3x equals 21, which means if we divide by 3, we're going to get x equals 7. Okay, so I'm going to plug 7 back into those segments first to find their length and to make sure that I did this correctly. So if I do 4 times 2, that's 28, and 28 plus 2 is 30. So we have that QP is 30. Okay, let me double check and make sure it works for QR as well. 7 times 7 is 49, and 49 minus 19, 30 as well. So we know that our 30, or x equals 7, is correct, and our 30 is a good length for that. Okay, so keep in mind that if these are tangents, not only are they congruent to each other, but they also are perpendicular to the radius. So what that does is that creates 2 right triangles. So I'm going to draw one of those. I'm going to draw QPU. So here's Q, here's P. I know that's 30. Then I have PU, which is the radius, and I don't know the radius. I'm just going to call that X. And then I've got QU, which was given to me. They said that was 34. So I can use the Pythagorean theorem to find the length of PU, which is the radius. And we're looking for ST, which is the diameter. So if I can find X, then I can double it to get the diameter. So PU is a leg, so X squared, QP is my other leg, plus 30 squared equals 34 squared, because QU is my hypotenuse. 30 squared is 900. 34 squared is 1156, 1156. We're going to subtract 900. So that gives me x squared equals 256. And then we're going to square root both sides. So that means that x is 16. So my radius is 16. That's true for PU, that's true for UR, that's true for SU, and that's true for TU. So now we're looking for ST, since it's a diameter. 16 plus 16, or 16 times 2, is 32. Our last tangent line property has to do with a circumscribed polygon. And a lot of times this is going to be triangles, but this does work for any other polygon. So earlier in the unit, we talked about inscribed. We talked about inscribed quadrilaterals, and that was a quadrilateral that was inside the circle. Circumscribed means that it's outside, it's around the circle, but it's still touching the circle. So in this picture, ABC, that triangle, is circumscribed around the circle. If that's true, then we know that all of those segments, all those sides are tangent lines. So AB is a tangent line, BC is a tangent line, AC is a tangent line to the circle because it touches at one specific point. And then here's the thing. If they're tangent lines, that means that those individual segments are going to be congruent. So BD and BE are going to be congruent using the last property that we had. And so will EC and FC. EC will not necessarily be the same length as BE, but EC and CF will be congruent to each other. And likewise, AF and AD. So it looks probably more confusing than it is, but let's try an example. Okay, so we are looking for the perimeter of triangle JKL. Perimeter is when you add the lengths of all of the sides. So the first thing we need to do is find out every side length. So let's see what we know. Because the triangle is circumscribed around the circle, that means we have a bunch of tangents. And if we have a bunch of tangents, then we know that LO and LM are going to have the same length. And I don't know anything about LO and LM yet, so I can't use that. I know that JM and JN will have the same length. I do have measurements for those, so I am going to set those equal to each other. I'm going to do 8x minus 35 equals 5x minus 8. I'm going to subtract 5x from both sides. I'm going to add 35 to both sides. And that is going to give me 3x equals, what is that, 27. I'm going to divide both sides by 3, and that's going to give me x equals 9. So now that I know that x equals 9, I can plug that back in. So if I do 5 times 9, which is 45, and then subtract 8, that is going to give me 37 for the length of JM. And we know that JN should also be 37, but instead of just assuming it's 37, I'm going to plug 9 in just to double check my work because we know we all can make mistakes. So 8 times 9, which is 72, and then minus 35, we did get 37, so that's great. All right, the other thing that we know is we know that NK and OK will be congruent as well. So I'm going to do pretty much the same thing I just did to find x. This is going to help me find y. So 7y minus 9 equals 2y plus 11. I'm going to subtract 2y from both sides, add 9 to both sides. That's going to give me 5y equals 20. Divide both sides by 5, y equals 4. And now I'm going to plug it in. So 7 times 4 is 28, and 28 minus 9 is 19. 2 times 4 is 8. 8 plus 11 is 19. So now if we're looking, we have the full length of LK, which is 32. That was given to us right there. The full length of JK will be 37 plus 19, which would be 56, but I don't have the full length of JL yet because I don't know ML. Okay, but what I do know is I can find OL. If LK, the whole segment, is 32, and I just figured out that OK is 19, I can do 32 minus 19, and that will give me the length of OL, which would be 13. And then that would make ML 13 as well, which would then make the whole length of that segment 13 plus 37, so that would be 50. So now to find my perimeter, I've got 32, which was given us, that was LK, JL is 50, and JK is 56. So I'm going to add 32, 50, and 56, which gives me 138 for the perimeter. And that is it.